Hello, welcome to our next webinar. That is our fifth webinar of AI4EOSC. My name is Marcin Puciennik and I will moderate this session. Basically, we'll have today four very interesting presentations on software development lifecycle, introduction to MLOps and MLFlow, OSCAR system for Inference, and AI4Compose. So during this whole talks, you can basically go to the Slido and paste your questions, put your questions. Basically, at the end of each presentations, we will have a Q&A session, and I will be reading the questions and basically ask speakers to provide their insights. So I will show also this QR code later after each of the talks. So don't worry if you didn't capture it yet now. So we are now going to the first presentation that will be done by Andres Heredia Canales, that is a researcher at the Advanced Computing and Science Group at Spanish National Research Council. He holds a master's degree in computer science and is currently a PhD student focused on the DevSecOps techniques and confidential computing platforms. So he has contributed to several projects like AI4EOSC, EOSC, and modernization of the Copernicus data store. So Andres, the floor is yours. You can start sharing your slides.
Thank you very much. Let me share my screen. Please confirm that you can see it.
Yes. Please put in full mode. Yes, I can see. So you can start, please.
Okay, perfect. So thank you very much, Marcin, for the nice presentation. Today we're going to talk about software development lifecycle and introduction to DevOps. Let's start with the agenda. First of all, what we're going to talk about. So we're going to try to define what is DevOps and then why do we need it. The challenge that DevOps is actually trying to solve. We're going to talk about the CI/CD pipeline, the tools that allow us to do this, and as well a road to DevOps or how to implement DevOps. Finally, we're going to finalize with some real-world examples and a little recap of what we saw today. So what actually is DevOps? Well, DevOps, it's really hard to define. It's an abstract concept. It doesn't have an accepted definition. So I took a couple of them that I found online that I like. For example, this one from Azure that says that it's a compound of development, dev, and operations ops. DevOps is the union of people, process, and technology to continually provide value to customers. This is one definition, and we have others that are even more extensive. For example, this one from AWS that says that DevOps is a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. This speed enables organizations to better serve their customers and compete more effectively in the market. Of course, these two definitions are focused on the kind of clients that AWS and Azure will have, so mostly cloud, and they're going to have maybe big clients that they want to serve and they want to be really dynamic. So as we can see, we don't have just one definition. So instead of trying to define what is DevOps, we are going to understand why do we need DevOps, and in that maybe we can understand what it's composed of. So why do we need DevOps? Let's try to explain this with an example. We're going to be a small company or not so small company, and we're going to be the next Facebook. Of course, we're going to get rich. So we have an idea, right? An amazing application that is going to make us rich. And you start gathering your requirements, what your application actually needs to do in order to satisfy your clients or your users. And you start coding right away these features. And as a good software or software engineer or developer, you test it and you already think that you're doing more than enough for this. So you're ready to deploy. You have already all your features ready and you're ready to be rich. You want to upload it to a server. But of course, to upload to a server, you need some kind of process of build and packaging, because every application is different. So it might be that it needs to be a jar, or it might be a web application. So every application has a different process for this. Once you have all that, congratulations, you have your first release. So you have your application up and running. And if you do care about your clients or your application itself, you should actually monitor. Um, you should monitor your application, so you can have some feedback on what's going on with your application, if it's up, if it's down, or just you want to add new features, right? So once you have this monitoring in place, you realize that you want to either fix a bug or you come with a new idea. And at the end, this process is, you see that it's not a straight line, and it's more of a circle. So you come with the idea, you got the requirements, you code it, you test, etc., and every time you do it over and over again to try to improve your application, right? So this is actually the challenge that DevOps tries to overcome, and it's quite a challenge because to deliver high quality code quickly is easier said than done, because there are some, or there could be some stoppers. So for example, historically, we had the developers and the operations and different teams, different departments, and they do all different things. So for example, the developers, they really consider where this application is going to get deployed. So they just code on their machines or the laptops, and they don't care about anything else. And they say, okay, operations, can you please deploy this? But operations doesn't even know how this application works. So it takes them a while to be able to decipher how or what does it need to be deployed and to be stable, to be up and running. Of course, there is a conflict of interest of both of them. They think that their work is the most important thing. So the developers, they just want more features to deliver more things as fast as possible. And operations wants to maintain stability and those sanity, mostly because operations, it's the kind of job that where if things are going right, they don't even remember that you exist. But when things go wrong, it's a living nightmare for you, because you have to come and fix it. Once this is up and running, okay, your new feature didn't break production, but what about security? Is it safe? So this is another big stopper that historically, maybe you have another team that does security, and you have a lot of bureaucracy. You have to fill out paper forms. You have to be compliant with some ISO, whatever. So it takes a while, as well as testing, because if you don't have a fully automated system where to do your testing that you can rely on, you at the end up as a developer doing some manual testing in your laptop, that it's a different environment as production, that even though it should work, it doesn't guarantee that it will in production. And finally, one of the biggest stoppers of them all, it's manual work. This is especially prevalent in the operations teams. It's really common to have one person or a team to SSH into a machine, into a VM, and to start installing libraries manually and to do some config files. And maybe you have just one person, then that person leaves. No one knows what he did or what she did and how to reproduce that. And anyway, it's slow and error prone because we are humans and mistakes happen. So this is some of the stoppers that you can find along the way, the roadmap of delivering a new feature. So this is what DevOps, it's trying to eliminate each one of these stoppers. So if we come back to this diagram, and we see that this circle, that is a cyclic process of delivering new features. If we twist it a little, we end up with the unofficial logo of DevOps that is basically a series of stages, is in the form of an infinite loop. And DevOps is trying to eliminate these roadblocks, these stoppers, using CI/CD, continuous integration, continuous delivery, as a core principle. So for the development part, the code is pushed often and is tested automatically and in a reliable way, as well as the new features don't take too long from being an idea to be up and running in production. So, this is for the development part. For the operations, one of the core principles is infrastructure as code to manage service and networks like software. That means that you won't have to be creating the VMs or the servers manually, especially, for example, if you want to move from one cloud provider to another. Let's say you want to move from AWS to Google. You can do that manually, but it's going to be a nightmare. So you want to have everything as code, so it's reliable and it's reproducible. And how do we do this? Well, there are many tools. As I say here, isn't one tool, is the whole orchestra. And I borrowed this image from the internet. And you can see that there are an overwhelming set of tools for each of the stages of the DevOps pipeline, the CI/CD pipeline. And it's really hard to keep track of all of them because sometimes, like it happens with JavaScript frameworks, a new one appears out of nowhere and you have to learn it because it becomes trendy and everyone is using it. So you have to adapt and you have to be really dynamic in that. The good news is that there is no need to learn them all at all. I don't even think that is possible, or it's efficient to learn them all. So how do you actually tackle this? I'm thinking that you have to, if you want to become a DevOps engineer, for example, you have to have some kind of hierarchy, some pyramid, some priorities, where you have to learn the basics and you have to focus on one tool at a time for each of the concepts, the core concepts that you need to know. For example, for well, of course, you need development concepts such as what is an if, what is for, algorithm, etc. Version control goes hand in hand with this one because you want to keep track of all your changes. And then you have the operations part that you have to learn. For example, Linux, most of the servers are running Linux, even though the desktops are usually Windows, right? But we want to operate with servers. Everything is connected nowadays, so you have to learn some networking as well as some security to not expose everything to the internet that is unsafe. Once you have all these basics, you can focus on learning some containers, maybe using Docker, for example. Most of the applications nowadays are delivered using containers. And to automate things, you can use a scripted language. Now that you have the development concepts, you can use Python, for example, as an scripted language. And if you want to publish your application, you can use some cloud provider like AWS. But again, you don't want to do things manually. You don't want to create all these servers by hand. So you use infrastructure as code, for example, using Terraform to create all these servers for you. Finally, once you reach here, you are already a DevOps engineer. You can start implementing CI/CD pipelines with a tool like Jenkins, and you can learn some container orchestrator like Kubernetes or Nomad. So you have replication, you have high availability of your Dockers containers. And finally, once you have your release, you want to monitor it using something like Prometheus, like we see in this example. And all this seems really complicated. Is anyone actually doing this? It seems like a lot of effort, and we are not sure if there are really big benefits from this, right? So the answer is yes. Everyone, all the big players are doing this. This is from the Phoenix Project, a really nice book in DevOps from 2014, so more than 10 years ago. And we can see that more than 10 years ago, Amazon was already deploying 23,000 times per day, and Facebook was releasing 1 time per day, for example, to put some examples. You can imagine the frequency that they have nowadays. I couldn't find numbers that are more up to date, but you can imagine that they just scale that maybe it's like tenfold, so 10 times this. And you have here the typical enterprise that is doing it once every 9 months. And this is good news because this was more than 10 years ago. This reduced a lot. And now the typical enterprise is more agile, is not using waterfall methodologies anymore. It's more delivering things quicker. But you don't have to be a big player to be able to use DevOps. So let's see an example, a real world example using the AI4EOSC project. And in this case, I'm going to focus especially in the dashboard. That is what I know, but the dashboard, the applications, all the tools that my colleagues are going to talk to you about are following the same principles. And we're going to go through each stage of the DevOps CI/CD pipeline to understand what we're using it and how it allows us to deliver new features quickly. So let's start with the code that we're using Git for versioning control through GitHub. We're uploading our all code there. It's public. You can enter, you can check it. And if you want to collaborate, you can do that as well. We're using conventional commits so that every new feature, every commit has a structure, and it allows us to gather all the changes in a changelog. And we can do a new release with all that. Let's draw here an IDE, for example, Visual Studio Code. It doesn't have to be that one, but let's say that we're using that one. And inside this one, we can use Husky Git hooks, for example, so that when we commit, we already have some testing, some checks beforehand before relying in the external testing system. So we have like a double check. It's even safer. We move to the build part. So, okay, you have your new feature, you want to collaborate, you code, you have your test, you create a PR in our GitHub, and automatically GitHub actions, a series of GitHub actions are going to check for dependencies, syntax, errors, etc. So it's basically try to build the app. And this is a substitute of Jenkins. What would Jenkins would do? We are doing it with GitHub Actions. In this case, it's building using Angular. Once it is already tested, when it's already built, it is the time for test. So we have different kind of testings, and we generate even a quality software report using SonarQube that we can check if the coverage is good, if this software has enough quality to be able to merge into main, right? Once this is all done, you have your test. You passed your test, so it's ready to check. This doesn't mean that your PR is going to be accepted, but it allows us to not have to lose time to do all of these things manually. So we arrive here as developers or maintainers of the dashboard, for example, and we already have a PR that is ready for checking, knowing that it builds, knowing that it doesn't have linting errors, knowing that it follows good practices, and that it passes the test and it has a good code coverage. So this PR is ready for check. If we accept it, another PR using, well, I put it here, a robot, we have the same as you see, the stale robot in the GitHub community. You are probably familiar with that. We have release please, that's some kind of bot that once we accept a PR is going to gather all the changes in a change log and is going to tell us, here's a proposal for a new release with a new number, and you can accept it or not. If you accept this PR and then a new release is created, we have a new tag for this new release. And finally, some other GitHub actions get triggered. This new release gets uploaded. The Docker image that we created gets uploaded to a registry. In this case, is Harbor instead of Docker Hub. And from Harbor, we call some webhooks that are in a server that are listening actively to that. Once you have this, the webhooks are going to deploy automatically at the deployment environment because we think that your feature is really nice. It passed the test, but we cannot just release it to production because it's not really tested in a real case scenario. So once we have it there, we beta test this release. So using either testers or inner users or just normal users that we can ask for them to access this development environment and to test to see if anything breaks and if they find anything to please report back to us if they find any bug or anything that doesn't work as it should. And finally, for monitoring, we have several systems that we're monitoring, and we're monitoring services such as traffic that allow us to route all your deployments or the dashboard. We're monitoring OpenStack, of course, the dashboard and the API itself, and it's the same as with all the deployments. So we have tools such as Uptime that is checking all the time if something is up and running, and if not, it's going to let us know through an email or a notification so we can act quickly. Once we finish with this, we go again and we plan new features, we code, we build, we test, etc., etc. You get it. And this, what it allows us is like to release new features quickly. We are not Facebook, we are not a big company, we're a small researchers group, but still you can see that we're able to release every week new releases, new features, and every maybe couple of days, maybe even every day, but especially every week we have some new feature or some bug that is fixed. So at the end, to recap, I won't be much longer. What is DevOps? We saw that DevOps isn't about a specific tool, is not about a methodology, it's not something that we can define just with a single definition, but it's more about culture, collaboration, and automation. It's something that is broad. It connects people, processes, and tools across the software lifecycle. It tries to eliminate these roadblocks that we saw, miscommunication, security testing, etc., etc. And when done right, it helps teams move faster and more safely so you can get new features and you can overcome this challenge of delivering quality code in a quick manner. And thank you so much for your attention. That will be all for my part. Again, my name is Andres Heredia. Here you have my email. And if you have any questions, I'm happy to try to answer them or to work on them if we don't have an answer to them. Thank you very much.
Thank you, Andres. Thank you very much. I will share now the, if you can stop sharing the screen, I will share again the QR code.
Yes.
Okay. So with this QR code, you can ask your questions. This is to all the audience. And I see there is some first question coming. So how much effort is required to set up such a pipeline like presented for AI4EOSC?
Yes, of course. The more complex your project is, the more complicated it's going to be, and the more time it's going to be. The important part here is the difference between if you're trying to implement it after you have your code, after you have your application up and running, and you want to change the way that you're working, or if you implement it since the beginning. If you implement it since the beginning, it's actually pretty easy since you have all these things in mind, and it shouldn't take much time to actually implement it.
Okay, thank you. So another question is, can you give some insights on how to use GitHub Actions for automating the processes?
Yes, I could give some insight. Yes, so basically, it's again going to depend. Maybe I don't know if I can share my screen and to try to.
Yeah, yes, I will stop to share my screen. Okay. Okay, you can now share this.
Yeah, so you can do things that are really simple. I actually would start with something like this. I wouldn't go too complicated. So for example, for the AI4EOSC dashboard, you can create a workflow that on each pull request, let's say for the branch main that you want to merge on main, you're going to check out your project and you're going to try to build it and you're going to try to pass some test. So this is the basic layout that you can use. You have many actions that are already ready to use, so you don't have to actually create new scripts from scratch. You can just use, and if you Google actions for either checkout repository or for how to run commands like this one, you can check that easily, and you don't have to go complicated. Once you have this ready, you can start adding new things or adding custom checks for your project. But I wouldn't go more than this for the beginning.
Okay, thank you. So the next question, what method or tool would you recommend for automated testing of a web service? For example, how to simulate user interaction with the user interface and ensure that the expected workflows are performed correctly?
For that, I would recommend Cypress. It's a tool that we are used for end-to-end testing, and it's really lightweight, and you can actually simulate what the user is going to do. There are some other frameworks, but they are more heavy to run. I would start with Cypress that supports actually many web service languages such as JavaScript.
Okay, thank you. And the last question, does one have to pay for SonarQube?
I think there are different plans. So you can self-host it and you don't have to pay for it. If you check the pricing in their website, I think there's under some conditions. I don't think that you can use it for whatever, but I'm not sure about this. But I'm pretty sure that you can use it for domestic projects, self-hosted for free, and then you have the option to have to use their service. So they host it, they have it in their cloud, and you can just use that one, and for that you have to pay.
Okay, Anders, thank you very much again for the presentation and all the responses. So we are now moving to the next presentation. So to introduction on MLOps and MLFlow demonstration by Lizana Berberi. So Lizana, you can start share your screen. So Lizana is a researcher at the Scientific Computing Center of Karlsruhe Institute of Technology in Germany. She holds a PhD in information system from Klagenfurt University in Austria. Her main interests include developing solutions in the field of machine learning operations, advanced database management, and the process management. She has been involved in different tasks in several EOSC-related projects, such as EOSC Pillar, Skills for EOSC, and AI4EOSC. So, Lizana, the floor is yours. We cannot hear you now. You have to unmute yourself, please.
Okay, sorry. Do you hear me now?
Yes, I can hear you now, so you can proceed, please.
Okay, thanks. Hello, everyone from my side. Thank you, Marcin, for your kind introduction. And in today's talk, I'm going to present in introduction to MLOps as streamlining the full machine learning life cycle, and then show you a demonstration of MLFlow service that we are running for our use cases in the AI4EOSC project. So this talk will be kind of divided in three main parts. I will shortly introduce MLOps, what is in a nutshell in its main components, and then some MLOps tools and platforms that we recommend to use for achieving a full mature level of automation, and then continue with the MLFlow demonstration as I mentioned, and to wrap up finally with some key takeaways. So as Andres already presented the DevOps, what I would like to make a comparison between MLOps. So first, MLOps stands for machine learning operations, and as you can see from this slide here is an extension of DevOps. And both of them are a set of practices and tools, but they differ that basically MLOps is to streamline the machine learning model lifecycle. Instead, DevOps, as Andres already mentioned, is to streamline the software development lifecycle. But as you can see, the DevOps, let's say, puzzle would contain only code infrastructure to run it and the environment. So these kind of pieces, but instead the MLOps will contain two more puzzle pieces, which are the data and model, and this way, so these additional elements will definitely add more complexity in streamlining, so in putting these models into production. Because we have to take care of both data and model, which means you have to collect the data, you have to process them, to validate, to version, and you have to take care of the quality of your data. Instead about the models, definitely you need to develop the models, you need to train them, version, and deploy these models. But they have some common goals, both of these, let's say, cultural set of practices as we already defined, and they are these main principles, the automation, so the both tries to reduce the manual work, and the CI/CD pipeline, so continuous integration and continuous delivery in order to deliver code and models fast and quickly. The reliability, meaning that you have to ensure that your system run smoothly without errors and no downtime. About the scalability, definitely while your let's say system grows, you have to ensure that you can easily handle more data or users or more models or versions of these models. If we look back to the history, and if we make just a search and try to check what are the most the search trends of AI-related topics, like you see here in this plot. So among data science, MLOps AI, LLM ops, and you can see that both MLOps and data science, they kind of started to mention as a term like in 2010, but definitely if we try to zoom in a bit, we can see that MLOps had a higher, let's say, interest in the 2015, and definitely we can see that kind of it's steadily, let's say, the interest in both the MLOps and the data science. Okay, now we will deep dive into MLOps components. So what basically we have to take care in trying to what are the best practices to put your models into production. And to explain easily that, we adapted the Google maturity level from Google in explaining this continuous delivery and automation pipelines in ML. So basically, this consists of 3 phases. Where you have to understand what level of automation you need to achieve for your use case. And So in the first level, so everything is done manually in managing this machine learning life cycle. So usually data engineers are responsible to extract and analyze their data. And here you have an experimental setup, complex process with some subtasks. And of course, first the data has to be prepared, then the model has to be trained, then to be evaluated and validated. So this is usually done in an experimental or in development environment. And as a next step, definitely there can be ML engineers or AI engineers who will store manually this model that has been trained into a model registry, which is kind of a centralized repository with a database as a backend. And then usually all the IT people that they are responsible to put this model into production as a service. But everything, as you can see, so from the legend here, everything is done manually. And of course, you can see different hands-off between different people and to achieve different tasks. And yeah, this is definitely could be error-prone and quite can take some time. But definitely this can be suitable for a case scenario where you do not need to frequently, let's say, deploy your machine learning models. And if we move to level 1, definitely now as the name of this level, it is machine learning pipeline automation. Definitely all of the tasks or these complex tasks that we introduced in level 0 will try to automate. And then here we see, for example, now these experiment set up with these subtasks that were mentioned earlier. They are right now, so in this level, they are orchestrated, meaning that there is already an order defined on how to execute each of these subtasks, so in what order. And definitely we introduce here this automated pipeline where so this is like interchangeably named with continuous training. And when in cases when we have new data, so new data may be arrived from the production, and you need to retrain then your model with this new data. But definitely first you have to validate the data. So if there are anomalies in this data, like in the data schema skews or in your data values, like the pattern of your data has changed. So you have to be assured about this first step, and then you can execute this. So this pipeline will be executed in this case, and the training on new data for your ML model will start. And as a next step, here during experimentation, you can push now your code. So data scientists now, your code should be modularized somehow, and they usually use notebooks or scripts, and you have to version control basically your ML code in order to track all the changes efficiently and collaborate continuously with your team. As the step, so the next step definitely will be the deployment of the pipeline, and then as the same step mentioned in the level 0, now this model will be stored into the model registry, and if there is this trained model which is performing better than the existing one running into production on the new arrived data, then you can select this model version, and then you deliver. So the preparatory for delivering this model is done automatically, but then again is a human usually IT staff will decide what and when, which model they are going to put into production. And definitely here as well, some triggers to trigger these ML pipeline can be activated. They can be like ad hoc triggers, or they can be on demand, like they can run on a daily basis or weekly, depending on the frequency of new data that might be arrived. And if these new data, yeah, they are quality data, and then you have to retrain your model. So as a summary, this level, yeah, it's about the automation of the machine learning pipeline, continuous delivery of the model, even though the deployment still during this phase is done manually. And if we move to the full mature level, the level 2, here basically everything, so the first steps work basically at the same as the level 1, and here actually we might have actually a feature store, which usually is a centralized store to store and access your features of the data set that you use as input to train your AI model. But as I said, this is optional. And then the new element, which is, again, is an automatic task that will be performed. So already Andres mentioned, actually, yeah, once you write your ML code, then you have to build and test all the packages and all their dependencies in order that everything will work the same between in a different, let's say, environment. And yeah, the next step then definitely will be the same, but here now the deployment of the model is done automatically through the continuous deployment of the new best performed model. So as a summarization, this level, it's everything of the previous level, like level 1 plus the automation of the CI/CD pipeline. Now we'll move to MLOps platforms and tools, and as here in the slide, there is a screenshot of the machine learning, artificial intelligence, and data landscape from Maturk. You can check the portal. I know it's hard to read, basically, what these icons and how they are grouped. But yeah, be assured that here there are 2011 logos, so from 2024. And from the previous year, so 2023, more than 500 icons, meaning that each icon corresponds to a new AI tool. As you can see, so MLOps is actually a booming ecosystem right now. But definitely this does not mean that, you have to know all of them. Of course, you have to select the one that you want and that will, basically fulfill your needs and requirements. And for that, as we saw, there's quite some different MLOps tools and even platforms out there. We decided last year to conduct a review study, and we successfully managed to publish in the Artificial Intelligence Review Journal. You have here the QR code, so you can have a look at it. And in this study, we proposed a three-step evaluation framework. Where we basically wanted to analyze these existing MLOps products, and with the aim to identify what are the critical features, so capabilities that a competent MLOps solution should have. And as you can see, the first step is we went through analyzing what are the criteria that we need to assess. We evaluated 16 MLOps open source across 10 different probabilities, and these probabilities were drawn basically from the AI infrastructure report and some insights from the academic literature. And as you can see here in the right side of this slide, you have a table screenshot where all these 16 products have been analyzed across different features. And for more detailed information, you can have a look at it. As a next step, then we assessed the average GitHub stars growth over the last years. We assigned a weight to each repository by normalizing their growth values to a range between 1 and 10, where the lowest growth receiving a weight of 1 and the highest growth receiving a weight of 10. So this metric basically highlights the industry, let's say, priorities and the adoption trends. So revealing which technical capabilities and tools developers find it the most valuable. Here you can see on the right side, there is this plot of the GitHub stars history from year 2019. And okay. And here you have kind of which of the tools basically had the most average, the highest average growth. And as a third step, then we finally calculated a weighted score for each repository by combining these average stars growth weights with the features that they support. So we counted the number of features basically. And the top 5 repositories with, here you have this screenshot of this table for each product, and you can see these 5, highlighted with a bold font style of the highest weighted scores, who achieved the highest weighted scores among these products. And yes, we can just kind of elaborate a bit about Kubeflow. So the first 3, let's say, Kubeflow, OneDB, and MLFlow. So Kubeflow had the highest score, but definitely there was like a peculiarity behind it, because in order to install computer Kubeflow, you had to have a Kubernetes infrastructure behind. And instead, for OneDB, let's say the free version that they are offering on the GitHub, it has only some limited features, not all the full features that the paid and cloud versions is offering. And that's why actually we use MLFlow as an experiment tracking server, as a model registry for our use cases in AI4EOSC. And before, let's say, moving to the demonstration, I just show you this nice image of what are the main components of MLFlow. So first of all, I'm not sure how familiar the audience is about MLFlow, but MLFlow is an open source platform to manage the machine learning lifecycle, and it is a tool being developed by Databricks, and I can say now, there's the interest, and they are highly developing features actually to mostly to LLM related stuff, and not so much to improving maybe some let's say some limited features that these machine learning lifecycle automation should achieve, let's say. And we can we can have a look onto the these components of MLFlow. Basically, there are 4. I haven't mentioned here the MLFlow evaluation, which is kind of a subcomponent, I would say. We have the tracking serve as a component, which is a very important one, and which we are actually offering. By using these component, you can log parameters, metrics, code the different artifacts during the experiments, which will help your team compare and produce results, definitely. So you don't need anymore manually to keep track of all this information, let's say, all these assets. And the projects, it standardizes the code, so it packages all your ML code, the dependencies, the workflows running, so this you will be ensured that they are portable and reproducible in different, let's say, environment. Then we have the model registry, which is a centralized repository, which will store your model versions, your the lifecycle stages, and the access control. And about the last one is the models. Basically, the models are packaged for deployment to a target environment. So basically, you select a version of your model, and then you can expose through the MLFlow model serve via a REST, via endpoint REST API. And now we can move to a demonstration of MLFlow with this short introduction. So, okay. I don't know if I need to zoom. Here you go to the dashboard portal of AI4EOSC. You have everything, so all the links via the QR codes, you can scan them later in my last slide. So we go here, and here basically you have the experiment tracking link, and if you go if you click there, then this basically window will pop up, and here this is kind of the workspace and all the information related to MLFlow tracking server. So you have experiments and models. What is an experiment? So for you to know, is like the main unit of organizing your machine learning code and your machine learning runs. And what is an MLFlow run? In MLFlow is basically a single execution of your machine learning code. And yes, as I mentioned, here are the different experiments, and if you click in one of the experiments, you have the different MLFlow runs that you have been able to log for a specific experiment. Beside that, if we move to the MLFlow Cloud, the sign up page, here we developed this new interface for our users to easily log in, let's say, using their OIDC, using the OIDC protocol via the AGI check-in. And as you can see, I will just enter my, I already did that. So you can use your received credentials, so it's easily for our users to register to this MLFlow instance. As you can see, there is this interface available for all the users, where basically, here you can change the password in case you want to, and there is a short information with your email address, if you're an admin or not, and here's the list of experiment permissions and the registered model permissions. This is, we found that is very important for our data scientists, because in case they want to share a specific experiment with their colleagues, let's say with their team, they can easily do that. So if I check, let me check. It does not make sense that, but anyway, just for you to show that. In this case, you type the email address of the user you want to share your experiment, and you click on what permission you want to assign to that user. So if you want just to read, or if you will be able to edit or manage, meaning with, he will have like full permissions on your experiment. And then you can click update, and so the permission will be assigned to this email address, so to this user. The same you can do for the registered model in your model registry. So here from the AI4EOSC, I will show you how you can log a concrete experiment. And yeah, I will just select one of the most popular, let's say, the modules in our dashboard is ULV8 model. So this object detection. And you can click here, and from the code space, you click Open in Jupyter Lab, and here you just name deployment for your set a name for your deployment. Then you decide which IDE you want to use in order to write your ML code, like Jupyter or DPass, and then you can next. Here you can define so the number of CPUs in this case, if you want to have a GPU in order to train this model. I will just say here you have the storage configuration. So I have already done this, so I'm not to spend some more time about that. You can add your data sets. So what data sets you want to use in order to train this ULV8 model on these custom data sets of yours. Then you can submit, and you can see that. So this is queued. It might take some minutes, but I have already this deployment running. As you can see here, you can click this IDE here, and you will be redirected to Jupyter Lab. So here you can go to the terminal, and you can check. So you can go to the AI, and you have everything either by using the interface or in the command line. So as you prefer. So I have already opened it, and here you can just run the DPass API, where each model basically is, let's say, interfaced with that. And in this case, you can see. Here, I'm sorry. So here you see that let me check. So you can see the API is running, and if you go to this Swagger interface and you want to train using this interface, you can easily do that. So you click here, so you click to this endpoint, and you specify what task you want to do. In this case, it's a detection. You put the reference model, ULV8, and here you specify the input data set, as I mentioned here. So here you can check, because this storage is already mounted. And I have, I can go storage, and so in this vehicle detection too, I have my data set. So I have these data sets that I want to use to train my this new model, and I can just copy this and put it as a reference and add the data unified configuration. Well, you can define the number of epochs here, but 100, it will take too long, I guess, but I can just put 10 just to showcase. I'm not sure if it will end by the time it's assigned, and you have to be sure that you need to enable MLFlow in this case in order that your experiments basically will be logged to our MLFlow cloud instance. Okay, let me check. So you can see that it's running. And if I go back here, so I won't wait for this experiment to be logged. I can just show you and mention the previous experiments that I already logged. Definitely, you have to first you set the experiment name, and you have you can go into the docs.ai4OS.eu, and you have here all the information that you need to know in order to successfully log your experiments into the MLFlow. So everything starts with this command. So within your train model function, you have to definitely write this command, and within this function, then there are specific commands in order what basically objects you want to log. If you want to log metrics, then you just type MLFlow.log metric. If you want to log parameters, then in this case you write down this, so you can have a look later at this one. And in case if you want to run, if you want to log the MLFlow as an artifact of your experiment, you can do that based, of course, on the flavor that you are using. So which framework you are using. If it's a TensorFlow, you type TensorFlow. If it's a PyTorch, but if it's a custom model, then it's we recommend to use the PyFunction. And here you, as an argument, you defined the model that you want to log and the artifacts of it, so the bar. And then you can register your model in this case programmatically by using that, but definitely you can do all of that. So registering your model using the user interface, I will show you in a minute. So if I just click into one of the recent runs, so you can see that for each run, basically it's a creation date, the data set that is logged as input, the duration, which user did that, what source, so the entry points that you executed for running that, what is the model that you logged. So basically here it will essentially just save the type of flavor that you used. And of course, you can add other columns in case you want which kind of metrics, as I showed you here, which are interesting to have is as a full view, let's say. If I click this one, as I was using, so here you have some more information about the status of your run, if it is finished or not, and of course for each run, you know, so under which experiment ID it was logged. And yeah, you can have a list of all parameters as you see here. Furthermore, if you go to model metrics, you can have a look at each of the metrics logs for each of the epochs. And for each of them, definitely, if you do not like so much, let's say, the layout here, you can store them as CSV file, and definitely then you can plot them using Matplotlib or another library as you prefer. Furthermore, you can log the system metrics of your experiment. So how much CPU or GPU percentage has been used during this experiment, and the list of artifacts. As you can see, for each model, you can infer the signature, which means what input and output has been produced for your model. And here you have the ML model package. So it will be saved with a pickle cloud format as well. You can see the list of arguments. You can see the detection results already stored. So there are different objects and information that you might be able to log as artifacts in this during your experiment run. And yeah, I think I'm out of time. So if I go back here, let's say I go to I want to save, I want to register, for instance, this model, and I click on that, and then I can register this model. If I have already this model, like the detect vehicle, because the data that I used for input was basically information about different type of vehicles, such as cars, motorcycles, vans, and so on. And here I click register, and you can see, as I already had a version of it, automatically a new version auto-incremented. So I will have this detect vehicle version 2. And furthermore, definitely you can add tags to your development status, for instance, pending or passes or whatever. Then for aliases, in order, if you want that to promote like this, this version of your model is having the best performance, and you can just use like some words at champion, and you can assign save aliases. Then you can promote furthermore this model between the different environments. So that can be that will easily handle the reproducibility. So I think I had it. So I explained everything I wanted to explain, and I can go back maybe to this last slide of key takeaways. So definitely MLOps is the critical process to scale machine learning beyond experimentation to production. And definitely you have to assess and to check which level of automation you want to achieve. And MLFlow is, we think it's very valuable even for starting your prototype. And on the right side, I think, you can scan all of this QR codes, and they will be redirected to the specific resource. Thank you for your attention.
Thank you, Lizana. Thank you very much. So if you allow me now to share the screen, I will remind again the QR code for the questions. So here in the Slido, you can basically put your questions. So first question, why MLFlow instead of other tools such as MLRun or Clear ML? The first question.
The question was why MLFlow instead of the others?
Or other tools such as MLRun or Clear ML.
Yeah, definitely. So MLRun and Clear ML they have kind of the same limitation of weight and biases as I mentioned. So in their free version, let's say they have only limited features, so they do not offer all the capabilities that I mentioned in my talk. Yeah, that's why.
Okay, another question: why there's distinction between IT staff and ML engineer at all, if AI is just yet another tool?
So why there is a distinction between IT
yes,
staff
between
and ML engineer?
IT staff and yes, if AI is just yet another tool.
What I can say, among these, let's say, between mainly the IT staff, they are responsible on the infrastructure itself. So where these usually the ML models are going to be put into production, and instead, machine learning engineers, they are more so their work is more concentrated into trying to automate these the different steps of an ML pipeline, as I mentioned, like validating their data and then training their models, checking the model performance, and so on.
Okay, Zana, thank you again for your presentation and all the responses.
Yeah, I'm sorry I took a bit more of your time.
Don't worry. So, okay, I stopped to share my slide, and we move now to OSCAR system for inference. So this will be presented by Amanda Carrabba Arayo. She is a senior researcher at GR-CAP research group at the Institute of Molecular Imaging at the Polytechnic University of Valencia since 2011. She received PhD degree in computer science from the same university in 2016. Her research interests are focused on cloud computing, serverless computing AI, and scientific computing. She has been working on different national and international research projects like Atmosphere, EOS Synergy, and AI4EOSC. She's a co-author of several research articles published in index journals and international conferences. So welcome, Amanda, and the floor is yours.
So thank you. Good morning, everyone. Thank you, Marcin, for the presentation. Can you confirm that you can see properly my screen?
Yes, we can hear and see.
Okay, thank you. So today, the goal of my presentation is to focus on the inference phase of the AI model lifecycle. And I want to provide you an overview of the OSCAR framework, that is the main tool that we use in AI4EOSC to perform inference. And for the ones that don't know still the tool, I want to give you a closer look to it. And the ones that already might have been working with it, I hope that you find more details of interest for your use case. So let me start by a brief introduction and defining what we understand by the term of inference. The inference phase of an AI model is the stage where an AI model is deployed and used to make prediction with new data. That means with data different from the one used for training. And this means also that we have previously, we have been coding, developing, build the AI model, and have been training the model appropriately. So in all of the phases that I have just mentioned, we have several challenges, but we are going to focus here in the challenges related to the inference phase. So mainly we have on the one side the scalability issue, and on the other side the wide variety of computing platforms that we might encounter. So what we understand about scalability, we refer to the ability of the computing platform to automatically scale and adapt its size to the workload of the infrastructure. So the usage of the resources is efficient and we do not waste the computing power that we have. On the other hand, what we understand about these multiple cloud platforms and so on, what we want to perform, we want to be able to do the inference at what we call the computing continuum, which is a scenario that encompasses several layers starting or finishing at the edge of the network, very close to where the data is being produced, and continuing with the on-premises layer where the institution can have resources, and also finishing in the cloud providers layer, which involve public, private, and also federated cloud providers. So we want to deploy our AI inference models in a platform that can work across these multiple cloud providers and multiple resource scenarios. And as my colleagues have presented previously with the DevOps culture, typically, currently what we do as AI model developers is that when we have finished the training of the model typically is packaged in a Docker container image to ease the distribution of the model. And what we need is a middleware layer that can work on top of this distributed computed platform. And this middleware is the one that will have to tackle all these challenges that we are mentioning. So how does the inference fit in the AI4EOSC dashboard? Okay, so some of you might already know this screenshot from past webinars or even from working with the AI4EOSC marketplace. But basically, what we find in the marketplace are several boxes, like this one, for example, that are the different AI models available in the platform. And there, when you link on one of them, what you see is something like this, is the details of the model, like the description, or the GitHub repo where the source code is available, among several other details. But most interesting are the three buttons that we have here. And the one that I'm going to focus here is the first one. This is the option when you want to deploy a model and to perform the inference with this serverless option that is OSCAR. And so to better understand what is underneath, let's start explaining what is OSCAR. Who is OSCAR? What is OSCAR? So this is an open source platform that supports serverless computing, the serverless computing paradigm. And by serverless, we understand the automated elasticity plus the event-driven execution. So when a user or a program uploads a file to an object storage system, this triggers automatically the execution of an application on a container on top of a container orchestration platform such as Kubernetes. So OSCAR, or an OSCAR cluster, can be deployed on top of multiple cloud infrastructures thanks to the infrastructure manager tool. You have there the link to this tool if you want to have more details in case you don't know IAM. And it also supports several computing architectures, such as this low power ARM-based device, which are very efficient, like Raspberry Pis. And this allows to do AI inference at the edge, very close to where the data is produced. So, how OSCAR achieved all these functionality? So let's take a very brief look at the OSCAR architecture diagram. Basically here, what we have is an object storage system in the middle of the image that is MinIO. And this MinIO is an object storage system where users can upload files into it. And once these files are uploaded, the inference is automatically triggered and triggers a job that executes on top of an elastic Kubernetes cluster that is able of automatically enlarge and shrink in terms of number of nodes, depending on the current workload of the cluster. And we also have elasticity at the level of Kubernetes, inside Kubernetes, in terms of concurrent pods. So OSCAR supports several storage backends, not only MinIO, but also the cache, like is one of more popular solutions used in science. Also OneData and Amazon S3, which, by the way, has the same API. It shares the API with MinIO. I'm not going to enter into much detail, but it's worth to mention that an OSCAR cluster is easily deployed through the infrastructure manager. Okay, so just regarding the components, I already mentioned almost all of them in the previous slide, but a brief overview. We are using infrastructure manager to deploy the clusters on top of multi-cloud providers, because infrastructure manager supports several public, private, and federated cloud providers. And thanks to CLUS, that is an elasticity manager, we can have this availability to enlarge and shrink a Kubernetes cluster that OSCAR is running on top of it. And then another interesting component that we will explore a bit more later is Knative. That is the component that allows us to run functions invoked through HTTP calls. And finally, as I mentioned, there are several backend solutions supported for the storage. So how does it work? How OSCAR works? So the main execution unit that we have in OSCAR is a service. And a service is defined using a functions definition language that is a language that facilitates to specify the details of a service using a YAML form. And what do we have to determine to create a service? Well, we have to determine minimum 4 things that needs to be added to the document. So the first one is the container image. As I mentioned, OSCAR runs the applications containerized on top of Kubernetes, and we need to specify for a service the container image that we want to use. Typically, this is a Docker Hub image, but also we support other repositories like GitHub or others. And then the second element is this script, that is the script, like you have here an example, that launches the execution of the model. For example, for the majority of the models in the AI4EOSC marketplace, you have the DPAS predict command, and as you see in the example, this is the command that starts the execution of the AI model. Then we have to add the requirements, the memory and CPU requirements for the service to run, for our model to run, and the last but not least important section is the input and output details that cover the storage services that we want to use. For example, by default, we can use Minio, but we can use also other solutions like the cache, and you have here an example to find more details. Okay, so how we can interact with OSCAR. Let's make a quick review about the different ways to work with OSCAR. First of all, OSCAR provides a graphical interface, a very nice interface that we have released last week. And this a new version. This is the dashboard that facilitates the usage for beginners, and also is more user friendly. So this dashboard is integrated with AI checking, also with Kcloak, and is very nice to use. Then for the programmatic work or access to OSCAR provides a REST API, and also a Python version to interact with OSCAR and all the capabilities it has. And last, we have also an OSCAR client, a command line interface, which is more convenient for experimented users. Okay, so once we have defined the service and we have created the service in OSCAR, how the service can be executed. So let's talk a bit about how we can execute our AI models in OSCAR. So we have mainly, as you can see in the slide, 3 approaches. The first one is what we call asynchronous calls. And this is the classic serverless approach, where the functions, or in this case, our AI models, are executed as a consequence of an event registered in a storage system. When we upload a file to a storage system, this triggers this execution. Then we have synchronous calls that are the response of an HTTP request directly that calls and the execution, request the execution of one of the models, one of the OSCAR services. And thirdly, we have the option to expose a service. And this means that we will have this application, this model, up and running continuously in the cluster, and it is commonly used to expose a web interface or a Swagger API interface and start listening in a specific part of the cluster. So let's see a bit more in detail each one of these 3 options, and I will show you also some short video demos to better understand the differences between them. So let's start with the OSCAR asynchronous call, and let's remind that we use a storage system as the main option to add files, and these files, when uploaded to the system, it triggers an event, and this event causes the execution of the model of the service. And once the execution is finished, the results are stored in the same bucket or in another bucket in another storage system. We can decide where we want to store the outputs. Even thinking a bit out of the box, we can use this Minio bucket as the input the output of a Minio bucket. It can be an input of the inference for another OSCAR service. And we can even create AI inference pipeline across multiple OSCAR clusters, but just connecting the inputs and output buckets of the services. So let's take a look at this simple video to invoke an OSCAR cluster, an OSCAR service asynchronously. Let me put this in full screen. So we log in with AI checking in this case. And with this new interface, what we are going to do is to select a service that has been previously created. And here you can see the Docker image we are using is the one that is available in the AI4EOSC marketplace. And here on the bottom, you can see the input and output min.io buckets that we are going to use. So as I mentioned, we are going to directly interact with the storage service. In case of min.io, we have this integrated in the dashboard, and we are going to select an image to upload to the bucket. As you see, we are in the bucket section. So we're going to use this image, and you can see also, even in the min.io object storage system, that we have added the image there. If we go to the service section and we search for the logs of this YOLO V8 service, we will see that a new job is running. Okay, so you see here that this has been triggered automatically thanks to the event that we have caused when we have uploaded the file to the min.io. So once it finishes, the output is saved in the min.io solution because we wanted like this. And if we go to the output bucket, we will see the image that has the labels of the YOLO V8 model detecting that we have two birds in the screen. Okay, so that's all for this very short video. Let me reload the presentation. And now let's take a closer look to the OSCAR synchronous invocation. So if you want to achieve low latency in your execution, let's say you see that we maybe we have a bit of delay from the event causes the triggering of the execution and the execution started. But if you want to directly call your model, your service to start running, what you can use is synchronous calls. And synchronous calls are scalable HTTP-based endpoints that we use underneath Knative to perform this synchronous invocation. So basically, Knative, what it does is maintains an active pool of Docker containers. They are up and running, allowing us to achieve a fast response time. So we are able to reduce this latency and to obtain the result in less than a second with this synchronous execution. So let's take a look to this second short demo to see how it works. And again, we are accessing the OSCAR dashboard, and we are going to also use YOLO, but in this case with a synchronous call. And what we are doing is we are going, again, we are checking that the Docker image is the one that we want. And you can see here the invoke button, and also this same button is there. And we are going to use this one to perform a synchronous call. And in this case, we are going to use another image. And what we do is to select the image and send it directly with an HTTP request to the service. So let me jump a bit because this image takes more time to be analyzed. Once the analysis is finished, you get the output of the model. In text, you get a base 64 format of the image, but you can put on image and see the outputs of the YOLO model. Okay, so let me again reload the presentation. Okay, and let's tackle the third model, the third way of executing the OSCAR services. And the last option is expose services. And here you have the ability to expose inside the OSCAR cluster a trained model with, for example, a DPaaS API accessible from outside of the cluster, so that the integration with other tools can be done at the level of the DPaaS API. And you don't need to interact with OSCAR. And then you can also benefit that if you have a model with big time to get the weights loaded in the memory, in this solution, the loads are only made once, so you are reducing this time, but you can achieve faster responses. However, the container is always running because it's always listening in a port, and this is the big difference from the other two approaches. This is less responsible, let's say, with the resources of the cluster, but is always waiting for your calls. Okay, so let's take a look to this functionality. In this case, we are going to use engines example. Well, we have two examples, but I'm going to cut it fast because for the sake of time. But here we are using the command line interface of OSCAR, and we are going to use this definition of the model. And we are going to see that we are creating with OSCAR apply command line command this model, and we will see that after some time, when the service is created, the endpoint of the engine servers starts working. And this will be there for us as long as the service is up and running in OSCAR. Okay, so you see here that we are creating these engine servers. If we go to the OSCAR services, we can find this service that has been just created. It's here, and then some seconds later, we have the engines server working. We have another example with the DPAS API, but I left it in the slides because I don't want to use more time. Okay, so just very briefly, I want to comment that we have an OSCAR CLI that is a command line interface that is more powerful than the web interface. But also you can do actions like in the command line, like in the web interface, like apply FDLs that you have seen in the video, invoke services synchronously. But you can also, and this is interesting, work with several OSCAR clusters in the same OSCAR CLI interface. And just to mention that this OSCAR CLI client is also integrated with AI checking. You just need to install the OEDC agent, and you have their documentation in case that you are interested. Okay, so let me come back to one of my first slides and analyzing how OSCAR is integrated in the AI4EOSC marketplace. We can easily create OSCAR service deployments of all the models that are available in our AI4EOSC marketplace by just selecting the OSCAR option. So let me show you this last video to see this in action. And as you can see, once we are logging, because you need to be logging to trigger this OSCAR deployment, you can search for the model that you want to test, that you want to perform the inference, and deploy it through the API serverless option. So this creates an OSCAR service deployment, and you can get the details of this service deployment here with the button. You can have here all the details of the service and how to interact with it. Because you can use it like asynchronous, synchronous calls, or you can directly use the endpoint to perform a curl, for example, request, or you can, with the mini.io details, start putting some files in the mini.io bucket and that causes asynchronous invocation. Okay, so because I know that this is a very, very short video because we don't have a lot of time, I left to you here also the link to the documentation where everything is explained and also the benefits of the solution. Okay, so just finishing my presentation, I want to mention some developments that we have made on top of OSCAR. One of them is OSCAR Batch. This is a simple tool that is very useful for performing the analysis of significant number a significant bigger number of files that need to be processed by an AI model. And this is a tool that is designed to perform batch-based processing and uses OSCAR underneath. So OSCAR batch includes a coordinator service where the user can provide the Minio bucket containing all the files that he or she wants to process, and the service calculates the optimal number of parallel service invocation and accommodates all of them within the cluster, distributing the image workload accordingly to the available resources that the cluster has. Also, and this is connected with the last presentation of today, we will see that we can use OSCAR services in tools like Elira and Node-RED to perform graphical composition of pipelines. And this easily, with a drag-and-drop approach, can be used to compose complex pipelines connecting several services or several AI models. So if you are interested in OSCAR, you can find more information in the official documentation of the tool. You have there the links, as well as in the A4 docs documentation. And we also maintain an active blog in which we include some news about the latest developments and some use cases coming from the several projects that work with OSCAR. And finally, you can also find some interesting video demos and several tutorials in the OSCAR playlist of our research group's YouTube channel. And just to finish my presentation, some remarks to take away. So OSCAR is used as the main inference solution, not only in AI4EOSC, but also in Imagine research projects to provide multimodal scalable inference of the pre-trained AI models. We are also using this OSCAR technology in InterTwin, supporting event data processing from the cache. And we have also integrated OSCAR with HPC clusters in order to provide a gateway from the cloud to the world into the HPC world to support event-driven computing in this kind of infrastructure. Just an invitation, you can go to the infrastructure manager right now if you want and deploy an OSCAR cluster for you in whichever cloud platform that you have access to. So you can deploy OSCAR to start playing with it with just some clicks. And to share, as I mentioned, recent news, we have this new version of the OSCAR dashboard available in that URL. So you can go to test it. And for the colleagues of AI4EOSC and Imagine use cases, we will update the corresponding OSCAR clusters very soon. But you can start playing with this new interface if you want, just indicating the input of the OSCAR cluster. Finally, the tools developed on top of OSCAR, that is OSCAR Batch, to efficiently execute the analysis of historical data, and the connection with the OSCAR services with the tools to graphically compose pipelines that my colleague Diego will present next. So that's all from my side. Thank you. You have there the link, my email. If you want to contact me for any question, I'm happy to solve all of them. Thank you.
Amanda, thank you very much for this very good presentation. So I will now share the slides with the QR code. So if people want to ask the questions, and actually we have first question that came during the presentation. So can OSCAR be used with models that are not in AI4EOSC marketplace? I think you partially already addressed it, but maybe you can follow up.
Yes, totally. Yes, OSCAR can work with AI models outside of the AI4EOSC platform. You just need to define the service appropriately. And as you have seen during the presentation, you just need to point to the Docker image that you have the model. Yes.
Okay, thank you. Another question, can you use the AI4 without retraining and only make the inference with a photo without logging, only for testing?
Yeah, well, without logging in the AI4EOSC dashboard, what you can do is you can use the try button. That is a Gradio deployment that allows you to test the service. With Oscar, you need to be part of the AI4EOSC platform. You need to enroll to use it. But also you can deploy for you an Oscar cluster and test it. But if you want to do it from the marketplace, you need to use the Try Me button.
Okay, thank you again, Amanda. I think we will have to move to next presentation. So thank you again. And I would like to welcome Diego Aguirre Ramirez for the last presentation on AI4Compose, composition of AI inference pipelines. So Diego is a senior technician at the Institute of Molecular Imaging at the Polytechnic University of Valencia. He studied computer science and completed his master degrees in 2024. He works mainly with Linux system, Git, Python, and Bash scripting. And he has contributed to the development of AI4Compose in the AI4EOSC project and assisted use cases in imaging with the Oscar integration. So, Diego, welcome, and the floor is yours.
Thank you. Can you hear me?
Yes, we can hear
Okay.
and we can see.
Okay. Well, today for this last presentation, I'm going to talk about AI4Compose, a proposal to focus on the composition of AI inference pipelines. And my goal is to show how we can automate and orchestrate AI models inference in a simple and reusable way. So, let me give you a quick introduction. Workflows help us helps the AI scientists run inference automatically, and using visual tools make this easier and faster. So, AI4Compose make a simpler way to create these workflows with a low code interface. This means you don't need to write much code or deal with a complex setup. It's also easy to learn, so not only scientists but anyone can use it, and this help more people access and use AI models in different research fields. Now, let me explain a bit the architecture of AI4Compose. As you can see, the user have two options that have the same steps. So when you have someone that want to use an existing AI model, for example, from the i4 dashboard, he can deploy it from Flowfuse with Node-RED or from Elira in a Jupyter environment. And both allows the user to build pipelines using visual tools. Now, for the Flowfuse pass, the users can create an instance in Node-RED and using components that are called Oscar nodes from a Node-RED library. That is like a repository of nodes that people upload to free use. It's like a open source repository for Node-RED users. And then when you use these modules or Oscar nodes, they will use a Oscar to make the inference and get the result that you can visualize in the work area. And in the Lyra works in a similar way. So the user creates the pipeline with components that uh, are called Oscar nodes too. In this case, the user can access to these nodes from the AI4Compose GitHub repository. And it's in the same way. You compose the pipeline, start the deploy, start the inference. This will send to Oscar the image that you want to analyze and get you back the result that also is visualized in the Jupyter notebook that you use in Lyra. So to now let's dive deeper into Lyra. So what is Lyra? And Lyra is an open source extension for Jupyter Lab, and it was created to help users build and manage machine learning workflows more easily. And with Lyra, you can create visual pipelines like the one you see in this image. And each block is a node that can be a Python script, an R script, or a Jupyter notebook. And Lyra is built in Python, so it supports many useful libraries for data analysis. For example, Pandas, NumPy, or Matplotlib, among others. And this makes much easier to manage complex tasks without writing everything from scratch. So for the another hand, on the other hand, we have Node-RED that is a flow-based programming tool, and in the same way as Elira, it helps you to use basic elements that are called nodes and connect it to make a pipeline. So like in the image, you can configure inference service without having a coding experience. So it's very easy to use for everyone. So before we talk a bit more about the Lyra and Node-RED, I want to mention Flowfuse because it plays an important role in how we manage the Node-RED's environment. So Flowfuse is a management tool platform for Node-RED, and we use it to have a central place where we can deploy an image, deploy and manage users and Node-RED instance. And the more important thing is that it supports full multi-tenancy, something that Node-RED doesn't offer by itself. So back into the presentation, maybe you have a question and is why and when using each tool. Uh, in this case, Elira is designed for data scientists who work usually with Jupyter Lab, so they are familiar with this environment, and every notebook is used to make the nodes in Elira. So it's especially useful for data processing and post-inference analyze. You will want to use it when you want to clean, transform, or study the results from the AI model results. On the other hand, you want to use Node-RED for quick deployment. This is because it's more easy than Elira in the ways that you only have to configure each node with a few steps. And in a short, Elira is great when we need structure and analysis, and Node-RED is perfect for fast results and easy integration. Let me explain you a quick example of how we work with these composing AI pipelines. For example, to use two models at the same time. So we start with an image. In this case, it's a planned image. we want to use the Graphi service that is deployed in Oscar, and from the AI4Compose tool, for example, using Elira or Node-RED, you will send this image to Oscar. Oscar will make the inference, return to you a result. For example, the image in grayscale. But this is not all, because you can use this output from this service as an input for the second one service. That is a plan service for classification. So once the first service is finished, they will trigger the inference of the second one. When the second one is finishes too, it will send you back to you the results that is in this case a JSON um, with the data of the plant that you upload in the image. Maybe with a video is more clear. So let me put to you this video. And I want to make a bit faster and start from here. Okay. Let me 1 second. From here. Okay, so this is the AGI environment. Is for well, you have a Jupyter environment, and as you can see, we have two nodes. The first one that is named create client is a script node that allows you to make an Oscar client and deploy services. Or use an already created services to use it. In this case, we want to use Oscar Graphics that you can see after a few setup of configuration, we can start the pipeline, and this will send the images that are in the input folder, and we will get back from Oscar, and you can see the results from the output folder, or you can go inside the node that is actually a notebook, and you can see the image from there from them. So now we want to use the most important thing that using inference tools, that is use 2 or 3 models at the same time. So in this case, we want to use again Graphi Oscar service and the Oscar plan service. So again, we have to configure the second one node, putting the plan's name and the input directory and the output directory. Notice that in this case we are using the output from the Graphi service as an input. We have to name the second output to put it in the output of the second one service. So after a few moments, this pipeline will send the image from the first service to the second one, and you can see. Sorry, this YouTube sometimes shows the thumbnails too soon. So we have here in this first service the grayscale image that you send to the service, and this second one we have the result of the classification with the image and the predicted levels with the percentage of the plants. So this is all for this example of Elira. Let me make again this. Okay. So now that we have seen how works Elira, let's use the same example for Node-RED. So in this case, you can see how is the FlowFuse interface that is the managed tool to use to deploy a different interface of Node-RED, and let's create an application that have an instance of Node-RED. So in this case, we name the application that can be the name of the project you want to deploy, and then you have to create the instance name. And as you can see, it's very easy to create an instance name. So the most important thing here is that Flowfuse allow us to create a templates that have a components that we have pre-programmed. In this case, Oscar nodes that directly works with Oscar. So we create the application, and then after a few moments, we will have able to enter in this node-ready instance. So now we are in the workplace, and you can see in this corner the Oscar nodes. So let me skip a few minutes to go to the important okay, to important example. So in this case, we want to prepare the same example of use to models, for example, Graphi and Oscar plans classification. So as you can see, we use a lot more of nodes because every node have only task. For example, the timestamp is an inject node that only starts the flow. The debug one is for you can see the results in the debug log, and the Oscar services are the the nodes that actually interact with Oscar. So as you can see, the composition is very easy. And you have to uh, only to organize these nodes, and in any moment you don't have to coding anything. So it's very easy to anyone to use this tool. So we have to prepare every node. As you can see, the input node is just to inject the data. This output is only to show you the results. The this image nodes is for you can see the results of the image in the work area of Node-RED. And let me make this a bit faster because it's a bit slow. Okay. The HTTP request, well, is for you can get, for example, in this case, an image for Wikipedia to use it directly or to make the inference. So, for example, in this case, it's a sunflower that we only get for Wikipedia and send to the Oscar node. And now we have to configure the first Oscar node. So you have to only to put in every gap the data. For example, you need the token of the service, the name of the service, and the server. That is actually the endpoint of the Oscar cluster. And in the second one is the same. You have to put the endpoint, the name of the service, and the token of the service. And we and now we can just start the pipeline just with clicking the input node, and this will start the inference. So we get the image from Wikipedia. This image is sent to the Oscar Graphi service that send the image to the Oscar cluster, and the service will turn you back the image in the grayscale. Then this image will be resent to the Oscar cluster oh, sorry, again the thumbnail, to the Oscar service, in this case the plan classification, and you will get in the return JSON with the data of the plan. As you can see here, well, believe me, it's here in this case. So this is all for the examples, and let me uh, make this again, this presentation. So to finish, we have some remarks about Elira and Node-RED. So Elira is already included in the AGI Notebooks platform, so you don't have to install anything, and you can start building workflows right away. However, it's important to mention that Elira can also be installed in any Jupyter environment, which gives you flexibility to those who prefer to work with locally or with custom setups. Is needed is needed workflows can also run inside the Oscar cluster because this is not mandatory, and it depends from the Oscar characteristics that you can maybe get access to CPU on GPU resources to speed up the inference. And finally, all the examples that we use it for the LiDAR are available in the AI4Compose GitHub repository. And every time that we can, are updating this repository with more no Elira Oscar nodes and more examples to use. And for in the case of Node-RED, again, the models are free to use and they are um published in the official Node-RED library, and you can use it directly from views that have the template with the Oscar, all the Oscar examples and Oscar nodes. So you only have to install in the application that you create the Oscar template, and you will ready to use all the Oscar support that you need. And to sum up, i4Compose offers to you a visual way to create AI inference pipelines using drag and drop tools and gives you an easy customization. And it helps you to minimize orchestration effort, and you can trigger multiple AI model service and combine them the results to improve the accuracy, for example. Um, it also supports reusable functions, so this allows us to give to have that all the examples that makes in repositories, and anyone who wants to replicate the same pipeline only has to get go to the repository of i4Compose and get the examples and the nodes that they want to use. And the workflows can run across different computing infrastructures, which means that i4Compose work even in a distributed environments. In this case, as we say, works with Oscar, the Oscar cluster, for example, the i4EOSC cluster and the Imagine cluster. And it's node in the workflow, it can be configured to call Oscar services. And 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 the last, as you can remember, FlowFuse is always a potent platform tool to allow us to use Node-RED instance and deploy the Node-RED instance with templates that already have Oscar examples and Oscar nodes. And that's all for this presentation. This is my email, and if you have any question, I will be agree to answer them.
Okay, Diego, thank you very much for your presentation. So I will now share this last time the screen with the QR code for any questions. So if you stop sharing.
Okay. There. Please, ready.
Okay, and let me share last time. And looking at the questions that we had been coming in the meantime. So can you summarize again when to use Evira and when to use Node-RED and FlowFuse?
Okay. Yeah. FlowFuse is not a composition tool. It's the platform where you use Node-RED. So you can see like an environment that give supports to Node-RED to, for example, have multiple users and multiple instances of Node-RED. And when to use Lyra or Node-RED, well, you want to use Lyra when you want to um have a complex when you have to make a lot of post-inference activities. For example, you can use the libraries of Python because it's a Jupyter environment, so every notebook use Python, and make the results more accurate or make samples or activities more complex activities to work with the data you get from the inference. And Node-RED in this case is more useful when you want to create a prototype or just a quick presentation of a AI model. For example, you want to show your model to your students or to another researcher, so you want to deploy a quick pipeline with Node-RED and make the quick and get the result very fast. So you put the image and get the result very easy, and that's the way.
Okay, thank you very much. And the last question that we have for today is, can this tool be used only from AI4EOSC or only for the modules in the AI4EOSC marketplace?
Um, Well, you can use both Elira and Node-RED in for others projects. For example, Imagine. We have already a node that is from the Imagine project, a fish detector, and every every node that we use is supported for I4EOS or every project that you need. So if you have your personal project, you can use one of our nodes, for example, to deploy the plant classification for your own. You don't need to be affiliated to the I4EOS project in this case.
Okay, thank you very much. So thank you again for this presentation. And I would like to thank you, all the speakers, for your today's presentations. And I would like to thank the audience for being with us for these last 2 hours. And we will send you soon invite for